In this video, we're going to pick up some of the most basic definitions for functions and their graphs. First, a relation. A relation is simply any set of ordered pairs. The set of all first components in the ordered pair is what we call the domain of a relation, and the set of all second components is what we call the range. Let's take a look at an example of a relation. Here I have listed a set of ordered pairs. If I need to find the domain of that set of ordered pairs, my domain is a set also, and it is the set of all the first coordinates in that set of ordered pairs. To find the range of that set of ordered pairs, I do exactly the same thing, except I look at this second coordinate. Now, as long as I'm looking at a set of ordered pairs, it's very, very simple to pull out domain and range. Domain is simply the first element in each ordered pair, and the range will then be the second coordinate there. The trick is going to be able to find it when it's more than just a relation. By more than just a simple relation, I mean a function. A function is a correspondence from a first set, the domain, to a second set, the range, such that each element in the domain corresponds to exactly one element in the range. What that means is that every time I give you an input, there is only one possible output. So if I have 17 in my domain and 17 goes to -3, every time we put 17 as an input, it must go to -3 as an output. Notice there is no restriction on that range. I can have every member of the domain going to -3 in the range, and that'll be fine so long as I don't have any x value that goes to two y values. Determining if I have a function is quite simple as long as I have a list of ordered pairs, because what I must do is look to each element in the domain, and if there's only one place for it to go in the range, it is a function. Do note this is what I was talking about on the last screen. I have both 6 and 8 going to 5. That is okay because 6 only has one place to go. He's only going to 5. Think of this as your class schedule. Each period of the day you have a specific place you're supposed to be. You do not have two places that you're supposed to be at the same time, but it may be that you go to the same room twice. That's okay because during first period and second period, you may be in room 10 both times. Now let's look at how to determine if I have a function based on an equation. If you take an equation and solve it for y, and more than one value of y can be obtained for a given value of x, one given value of x, then the equation does not define y as a function of x. Let's see what that means. Okay, so determining a function from an equation, if I were to solve this first one for y, I would start out by subtracting x squared from both sides. Then I would take the square root. But as I'm writing the symbol, I'm thinking, wait, that symbol meant principal square root. And why did we have to specify? Because there were two possibilities, a positive and a negative. So for a single value of x, even just pick 0, okay, then I have y is positive or negative square root of 1 minus 0, which is 1, which means y could be positive 1 or it could be negative 1. So for one value of x, I have two values of y, so this is not a function. Anytime you square y, he will not be a function. Okay, second equation, I hope you recognize it as an absolute value function. It is a function because no matter what you plug in for x, there's only one possible answer for y. Doesn't matter what you plug in, you're going to multiply it by 2, and there's only one answer to that. Subtract 5, only one answer for that. So adding, subtracting, multiplying, dividing, those all just give me one possible answer. So therefore it is a function. Likewise, on the last equation, if I solved it for y, I'd start off by subtracting 2x on both sides and then dividing everything by 3. And with the exception of placement, I think I recognize that as a linear function. It is a function because, once again, whatever you plug in for x, I am going to only get one possible y value because I'm simply adding, subtracting, multiplying.